Drivers and their driven equipment play important roles in many industrial processes. During operation, the shaft of the driver turns and transmits power to the shaft of the driven equipment. For this transmission of power to occur, the shafts must be connected. Many different types of equipment drive components can be used to connect shafts and transmit the power. Basically, equipment drive components are devices located between a driver and its driven equipment. Their main function is to connect a driver to the driven equipment so that power is transmitted to the driven equipment. Some types of equipment drive components have additional functions. For example, this belt drive system enables the driver and the driven equipment to operate at different speeds. This fluid coupling accomplishes another function. It enables the speed of the driven equipment to be varied. Another function that some components provide is to connect and disconnect shafts. For example, this clutch can connect and disconnect the driver from its driven equipment. Each equipment drive component may have specific procedures or precautions associated with it. However, there are some safety measures and operating checks that apply to all types of equipment drive components. As with any type of rotating equipment, operators must be careful not to get clothing, tools, hands, or feet caught in moving parts. To protect personnel, most drive components have some type of guard or cover. Operators may be responsible for ensuring that the guard is in place whenever a drive component is operating. Operators should also check the physical condition of drive components. Any damage should be reported. Operators should listen to the components for any unusual noises and watch the shafts to see if they're turning smoothly. Operators should be familiar with the normal operation of the drive components they're responsible for. Early detection and reporting of problems can help prevent dangerous conditions. Each type of equipment drive component has unique capabilities. Different types of components are often used together in order to utilize the unique capabilities of each. The reasons why different drive components are selected is based on the operating characteristics of the rotating equipment and the requirements of the installation. Let's take a look at an example to see what this means. In this example, a diesel motor is used to drive a circulating water pump. The motor isn't mounted directly in line with the pump it drives, so a gearbox is used to turn the direction of the shaft. The couplings that are used absorb the surges that occur when the motor is started and brought up to speed. There are many operating characteristics of drivers and driven equipment that equipment drive components may be designed to handle. For example, many of these components handle torque. Torque is a turning or twisting force. Normally, this force is created by the driver and transmitted through the drive components to the driven equipment. As the temperature increases, the materials expand. When the equipment is shut down, the materials cool and contract. Rotating equipment and equipment drive components are designed to allow for expansion and contraction. For example, the shafts normally have a small amount of freedom to move axially, that is, from end to end. The amount of axial movement that the equipment allows is often called end play or end float. Now, even though equipment drive components are built to withstand most stresses, they can eventually wear out and fail. As an operator, you need to look for signs of wear when you inspect equipment drive components. You also need to be aware that operating equipment improperly can create excessive stress, which can damage equipment drive components. When an equipment drive component is used to increase shaft speed, the amount of torque decreases. On the other hand, when an equipment drive component is used to decrease shaft speed, the amount of torque increases. A torque surge is a sudden change or surge in the torque from a driver. It can occur whenever a driver is started or stopped, or when the speed of the driver is changed. Another type of sudden change is a shock load. Shock loads are sudden changes in the load placed on the driven equipment that suddenly change the amount of power required by the equipment. Shock loads and torque surges both create stress on equipment drive components. Stress is also created by temperature changes. During operation, rotating equipment usually generates some amount of heat. This causes the temperature of the materials that the equipment is made of to increase. In this topic, we've introduced some basic information about equipment drive components. We also looked at some of the characteristics that are important to the operation of equipment drive components. Now try some practice questions on this material. Basically, equipment drive components are devices located between a driver and its driven equipment. Their main function is to connect a driver to the driven equipment so that power is transmitted to the driven equipment. Torque is a turning or twisting force. Normally, this force is created by the driver and transmitted through the drive components to the driven equipment. With rotating equipment, torque and speed are interrelated. Couplings are used to connect the shaft of a driver directly to the shaft of a piece of driven equipment. Couplings can be grouped into two basic categories: fixed speed couplings and variable speed couplings. Fixed speed couplings are used for applications in which the driver and the driven equipment must operate at the same speed. There are basically two types of fixed speed couplings: rigid couplings and flexible couplings. Rigid couplings are couplings that do not give or bend. They also do not allow for misalignment between the shafts they connect. Since in many cases the shafts of the driver and the driven equipment are not perfectly aligned, rigid couplings have a limited range of use. One common type of rigid coupling is a flanged face coupling, which consists of two flanges that are bolted together. Another rigid coupling is a spool piece coupling. It has two sets of flanges that are connected together by a short section of shaft called a spool piece. The most widely used fixed-speed couplings are flexible couplings. Although these couplings come in a wide variety of designs, they all have at least one part that can flex or give. Different types of flexible couplings can compensate for the effects of shaft misalignment, temperature changes, torque surges, and shock loads. One type of flexible coupling is a jaw coupling. A jaw coupling consists of two hubs that have jaws and an insert. The insert is usually made of plastic or rubber, and it serves as a flexible buffer between the shafts. The insert allows the jaw coupling to compensate for some misalignment and for expansion and contraction of the shafts. Another common type of flexible coupling is a grid coupling. The main parts of a grid coupling are a grid and two grooved hubs. The grid is a strip of springy, flexible steel that fits into grooves in the hubs. The grid transfers power from one hub to the other. It can flex to cushion surges in torque from the driver or surges in load from the driven equipment. The grid can also slip in the grooves, which allows for some axial movement between the hubs. Since there may be some movement between the grid and the hubs, a grid coupling requires lubrication to prevent it from wearing out prematurely. Seals between the cover and the hubs help to keep the lubricant inside the coupling. Another type of flexible coupling is a gear coupling. A gear coupling consists of two hubs with gear teeth and a sleeve that has gear teeth on the inside. During equipment operation, the gear teeth on the hubs mesh with the gear teeth in the sleeve. Gear couplings are able to compensate for small amounts of misalignment between the shafts they connect. They also allow for small amounts of shaft axial movement. The lubricant is used to reduce the wear that occurs between the teeth. The lubricant also helps to dissipate heat that is generated. Seals help to contain the lubricant. Another type of flexible coupling is a universal joint. Universal joints are used to connect shafts that are at an angle to each other. A universal joint consists of two U-shaped yoke arms that are joined by a cross-shaped piece. The cross-shaped piece has a bearing on each end of the cross. This arrangement allows the yoke arms to swivel on the cross piece with minimum friction. Universal joints allow for a great deal of misalignment between the shafts they connect. However, they work best when the angle between the shafts is less than 45 degrees. Bearings in universal joints are constantly pivoting and generating heat. As their speed increases, more heat is produced. Because of this, universal joints are used in applications where speed is relatively low. The bearings on a universal joint require lubrication. The crosspiece typically has a grease fitting that allows grease to be added. Like all other types of rotating equipment, fixed speed couplings should be checked periodically. Operators should make sure that the coupling guard is properly in place. Operators should also look for any signs of damage or lubricant leaks. Operators should listen to the couplings when they're operating. Any unusual noise may indicate a problem. Also, operators should check to see if the shafts are turning smoothly. Variable speed couplings enable a driver and its driven equipment to operate at different speeds. Specifically, variable speed couplings allow the speed of the driven equipment to be varied while the speed of the driver remains constant. Most variable speed couplings have two major elements, the driver element and the driven element. The driver element is connected to the shaft of the driver, and the driven element is connected to the shaft of the driven equipment. In most applications, the speeds of the driver element and the driven element are different. The difference in speed is called slip. Two common types of variable speed couplings are fluid or hydraulic couplings and magnetic or electromagnetic couplings. Fluid couplings use a fluid, such as oil, to transfer power to the driven equipment. Magnetic couplings use magnetic force. This is an illustration of one type of fluid coupling. Inside the casing, the coupling consists of two bowls, one here and one here. Each bowl contains a group of vanes. The inside of the casing is filled with oil. The bowl on the driver element is often referred to as an impeller. The bowl on the driven equipment is often called a runner. When the impeller spins, the vanes in the impeller cause the oil to flow in a circular motion. When the circular flowing oil contacts the runner, it transfers power to the runner. This causes the runner to spin. The amount of slip that occurs is controlled by varying the amount of oil in the bowls. If the bowls are filled completely, there is very little slip. If the amount of oil in the bowls is reduced, the amount of slip increases. When slip increases, the speed of the driven equipment is lowered. During operation, the spinning oil creates heat that must be removed. Many fluid couplings have a cooler to keep the oil from becoming too hot. Another type of variable speed coupling is the magnetic coupling. This type of coupling uses the interaction between magnetic fields to transfer torque from the driver to the driven equipment. This is a simplified illustration of one type of magnetic coupling. The coupling consists of two rotating elements, the driver element and the driven element. The driver element is an electromagnet. Electric current is supplied to the electromagnet and creates a magnetic field. When the driver rotates the driver element, the magnetic field also rotates. The rotating magnetic field created by the driver element produces a magnetic field in the driven element. The two fields interact and cause the driven element to follow the rotation of the driver element. The speeds of the driven equipment and the driver are always different, since there is always some amount of slip. In magnetic couplings, the amount of slip is controlled by the strength of the driver element's magnetic field. The strength of the field depends primarily on the amount of electric current that is supplied to the driver's electromagnet. Basically, the more current supplied to the electromagnet, the less slip, and the driven equipment will rotate faster. On the other hand, if less current is supplied to the electromagnet, there will be more slip and the speed of the driven equipment will be slower. Like other types of rotating equipment, fluid couplings and magnetic couplings should be checked periodically to see if they're operating properly. Operators may be required to check the level of fluid in a fluid coupling reservoir. If the amount is too low, the coupling may not operate properly. Operators may be required to check the operation of a coupling's cooling system. If it's not operating properly, the coupling may overheat and be damaged. On variable speed couplings, operators should check the speed of the driven equipment. They should also verify that the amount of slip is at the desired value. In this topic, we've looked at two types of equipment drive components: fixed speed couplings and variable speed couplings. Now take a moment to try some practice questions on this material. Rigid couplings are couplings that do not give or bend. They also do not allow for misalignment between the shafts they connect. Since in many cases the shafts of the driver and the driven equipment are not perfectly aligned, rigid couplings have a limited range of use. One common type of rigid coupling is a flanged face coupling, which consists of two flanges that are bolted together. Another rigid coupling is a spool piece coupling. It has two sets of flanges that are connected together by a short section of shaft called a spool piece. Two common types of variable speed couplings are fluid or hydraulic couplings and magnetic or electromagnetic couplings. Fluid couplings use a fluid, such as oil, to transfer power to the driven equipment. Magnetic couplings use magnetic force. This is an illustration of one type of fluid coupling. Inside the casing, the coupling consists of two bowls, one here and one here. Each bowl contains a group of vanes. The inside of the casing is filled with oil. The bowl on the driver element is often referred to as an impeller. The bowl on the driven equipment is often called a runner. When the impeller spins, the vanes in the impeller cause the oil to flow in a circular motion. When the circular flowing oil contacts the runner, it transfers power to the runner. This causes the runner to spin. Clutches are a specialized type of equipment drive component. They allow the shafts of a driver and its driven equipment to be engaged and disengaged. When a clutch is used, one piece of equipment can continue to run while the other is disconnected and stopped. The two pieces of equipment can also be reconnected during operation. In some applications, clutches are used as safety devices. These clutches disengage when the torque from the driver exceeds the clutch's maximum rating. When this happens, the rotating equipment is protected from being overloaded and possibly damaged. One of the most common types of clutches used is a disc or plate clutch. When this type of clutch is used, torque is transmitted from the shaft of the driver to the shaft of the driven equipment by friction between surfaces in contact. This is a simplified illustration of a disc clutch. It includes a set of friction plates connected to the drive shaft, a set of friction discs connected to the driven shaft, a pressure plate, and an air diaphragm. On this clutch, the drive shaft is hollow. It provides a means for supplying air to the air diaphragm. During operation, when the clutch is disengaged, the drive shaft turns the diaphragm and the set of friction plates. During normal clutch operation, air is supplied to the diaphragm. When air is supplied to the diaphragm, the air works against the diaphragm. This causes the diaphragm to move, and it pushes against the pressure plate, causing all of the plates to move and come into contact with the friction discs. The friction between the plates and the discs transmits torque from the driver to the driven equipment. The speed of the driven shaft will quickly increase until it matches the speed of the drive shaft. To disengage the clutch, the air supplied to the air diaphragm is released, and the diaphragm moves back, pulling the plates away from the discs. Since there is no longer any friction to keep the shafts rotating together, the shaft of the driven equipment stops. Monitoring and controlling a disc clutch is usually done from a control panel. This allows operators to monitor the operation of the clutch and to engage or disengage the clutch. Clutches, like other types of equipment drive components, require periodic inspections to ensure proper operation. As an operator, it may be your responsibility to make these inspections. One of the basic checks that should be made is for any abnormal noise or vibration, which could indicate that the clutch overheated and is now damaged. One cause of overheating is improper cooling. Most clutches require some amount of cooling. The cooling removes the heat that's generated when the clutch is engaged or disengaged. Heat may also be generated if there is any slip during the normal operation of the clutch. If the clutch is air-cooled, the operator should make sure that air is able to flow around the clutch properly. If the clutch is water-cooled, the operator should make sure that the cooling system is operating properly. Cooling water system pressures and temperatures should be checked to make sure that they're at proper values, and the system should be checked for signs of leaks. The clutch should also be checked for overheating. Excessive heat may be an indication that the clutch is slipping or that there is a cooling system problem. Excessive heat can eventually burn up a clutch. Some clutch control panels have an indicator that shows the amount of torque that is being transferred. The indication should be relatively steady. If it's not, it may be a sign that the clutch is slipping. Any indication that a clutch is slipping should be reported to a supervisor. In general, a clutch should engage and stay engaged without slipping until an operator disengages it. In this topic, we looked at the operation of a clutch, and we examined some of the basic checks that operators should make on clutches. Now try some practice questions on this material. When air is supplied to the diaphragm, the air works against the diaphragm. This causes the diaphragm to move, and it pushes against the pressure plate, causing all of the plates to move and come into contact with the friction discs. The friction between the plates and the discs transmits torque from the driver to the driven equipment. The speed of the driven shaft will quickly increase until it matches the speed of the drive shaft. The clutch should also be checked for overheating. Excessive heat may be an indication that the clutch is slipping or that there is a cooling system problem. Excessive heat can eventually burn up a clutch.